Assalamualaikum warahmatullahi wabarakatuh. We from Group 5C. Today we would like to present our video presentation which is Third Wave Technology Photonic. Our group members are Jazrin Eliza Joseph, Lukman Nur Hakim bin Nur Jafni, Muhammad Afiq Shazani bin Zawawi, Muhammad Fakrul Razi bin Nurdin, and me, Nur Atiyah binti Suhaimi. Photonic is the science of light. It is the technology of generating, controlling, and detecting light wave and photon, which are particles of light. The characteristic of the wave and photon can be used to explore the universe, cure disease, and even to solve crime. Scientists have been studying light for hundreds of years. Photonic explores a wider variety of wavelengths, from gamma ray to radio, including X-ray, ultraviolet, and infrared light. Photonic is probably the outstanding candidate of the principal enabling technology of the 21st century.
Background history. This is the background history for the photonics. Photonics is derived from the Greek word phos, meaning light, which has genitive case photos, and in compound words, the word photo is used. The word photonics, it appeared in the late 1960s to describe a research field whose goal was to use light to perform functions that traditionally fell within the typical domain of electronics, such as telecommunication, information processing, etc. This term photonics was coined by the French physicist Pierre Adrien in 1967 and is widely used since the mid-1970s. Photonics as a field began with the invention of the laser in 1960. Other than that, it also created a laser diode in 1970s, optical fibers for transmitting information, and the ABM throughput fiber amplifier. This invention formed the basics for the telecommunication revolution of the late 20th century and provided the infrastructure for the internet. The term photonics came into common use in the 1980s as fiber optic data transmission was adopted by telecommunication network operators. Its use was confirmed when the IEEE Laser and Electro-Optic Society established an archival journal named Photonics Technology Letters at the end of the 1980s. During the period leading up to the dot-com crash circa 2001, photonics as a field focused largely on optical telecommunications. However, photonics cover a huge range of science and technology applications, including laser manufacturing, biology, and chemical sensing, medical diagnostic, and therapy, display technology, and optical computing in 1970. Corning glass work demonstrate highly transparent fibers, and Bell Laboratories demonstrate semiconductor laser that could operate at a room temperature. This demonstration helped establish the feasibility of fiber optic communications.
So, let's get into the application of photonics. Photonics has application in almost every aspect of our existence, from daily life to cutting-edge science. Just a few examples include information processing, telecommunications, and medical field. For information processing and telecommunication, photonic device has commercially important use in fiber optic telecommunications, optical data storage, display, optical pumping of high power lasers and laser printing. For medical field, it will be help in medical diagnostic, organic synthesis, information and communication, and fusion energy. So these are few of application for photonics. First is optical communication. In a normal optical link, the data is transferred from electrical to the optical domain using an electro-optic modulator. So what I mean by that is the data that been transferred from electrical to optical domain by using a modulator. This modulator can vary the intensity and or the phase of optical carrier. In silicon optics, a widely used technique to achieve modulation is to vary the density of free charge barrier. So in the modulator, the technique used to alter the data is by vary the density of free charge barriers. So on the receiver side, the optical signal is typically converted back to the electrical domain using a semiconductor photodetector. Second is optical routers and signal processors. Tasks which are conventionally performed by manipulating signals in electronic form are done directly in optical form. For example, optical switching, where the routing of optical signals is directly controlled by other optical signals. And the third one is long-range telecommunications. Silicon photonics can increase the internet's bandwidth capacity by providing microscale ultra-low power devices. So in telecommunications, silicon photonics can help increase the internet's bandwidth so that it can reach more users in their smartphone for the better internet.
I will continue this presentation to talk about the future trends of photonics. The future trends of photonics is medical field, communications, transportation, and energy. Medical field. In the past, it was unfathomable to have a complete scan of the human body to search for disease and abnormalities. But with the investment of photonic technologies, the X-ray and CT scans made these actions possible. At the same time as more sophisticated photonics-based techniques and equipment are realized, the adaptation of smart mobile devices for field work shows tantalizing promise to bring medical tests into homes. It will be important to find economic support to deploy this through the developing areas of the world that lack loyal physicians and medical equipment. This will truly change the world for the better, as people who lack accessibility to medical needs will be able to discern any disease they may have through the lens of their smartphones. Communications. In the present now, we can already see the capabilities and advantage photonic technologies bring to our society. In our communities, communication plays a big role for it to function properly. Today, we may be able to talk to our relatives through a screen, but who knows, in the near future, with the help of photonics, we'll be able to interact and spend time with people who are physically far away from us. VR, AR, and MR are applications of photonics undergoing intense development. While the concepts are not new, market realization seems imminent. With the advance in the photonics headgear and the affordable processing power, this concept also shows promise for medical applications trending in the industries. I will pass this presentation to Jezreel.
Now, moving on, the future trends of photonics in transportations. The highly competitive automotive manufacturing sector has been adopting aspects of Industry 4.0, which is a photonics-based industry. And while there is a lot of excitement around autonomous vehicles, photonic sensors are already making driving safer, I am reminded when I drive an older model car of the benefits of rear view cameras and blind spot detectors. The camera-enabled autopilot features of an electric car is another glimpse of the possible future. Photonic gyros in every large passenger plane make these giant carriers already almost autonomous. Laser measurements of speed and wind will likely be implemented to further make transportation safer. Photonics will continue to improve transportation system of all kinds in ways proposed before the photonics technology was ready and affordable, and in ways we have not yet thought of. This also includes the development of AI. Meanwhile, in the energy department, one of the successes of photonics has been the adoption of solar power. Around 100 gigawatts of solar generation was added across the world in 2017. The transition to solar and other renewables remains far from complete, of course, with all renewables producing still only around 20% in the US. Solar energy is economically competitive today and can be made more so with further photonic engineering. Storage. The worries of already capitalized polluting power generation and its associated grid and politics are slowing the adoption of solar energy. But solar is becoming a preferred energy source for new power generation plants. Whether the fossil fuel era ends due to the decreasing supplies, or better, due to the moves to protect our fragile planet, photons will play a major role in providing part of a better alternative. In conclusion, photonics technology has a really high potential for development. This can be seen through numerous ideas and possibilities that comes with it. It is our hope that photonics will continue to develop and better the world. Thank you. That is all from our group.